All right, I'm going to show you guys how to use dimensional analysis as will be required for my courses. I'll try to keep this video brief, and I apologize. I'm very sick, so I'm talking without a working nose, so my voice, which is already annoying, sounds even worse. So sorry about that. But dimensional analysis, as used for my class and for any class, actually, it's just a tool to convert between units. It's something that everyone already kind of knows how to do in their head intuitively, but dimensional analysis just makes it, it just gives you some steps to follow, especially when you get to the complicated questions of chemistry, where you have to convert between moles and number of atoms and some other things. It can get a little complicated. So dimensional analysis just gives you a very easy set of steps to follow. And it's useful for easy problems and for those complicated problems. But for this example, for this video, we're going to use a very simple question. And also the steps that we're going to follow. If you've had my class before, the steps that I'm going to show you on here are a little different than what I have given you on PowerPoints and stuff before. But it's the same. Essentially, it's the same steps, pretty much. It's a little bit more thorough with these 8 steps I have listed here. So you'll want to pause the video, jot them down, because I don't want to waste too much time just showing these. Dimensional analysis is just a way to convert between units. So it's like when someone asks you how many quarters you need to have $18, or how many days are in 3 weeks, or how many inches you have in 10 centimeters. To answer those 3 types of questions, you need to know the relationship between the 2 things you're talking about. If you're talking about quarters and dollars, we know that 4 quarters make $1. If you're talking about weeks and days, we know 7 days is a week, and we know that 2.54 centimeters is 1 inch. Dimensional analysis is a way for you to use that given info, these 3 things I have written here in color, that given relationship for each of these things, you're going to use that to convert between something you don't know. For instance, I said that $1 has 4 quarters in it. Well, what if I want to know how many quarters I need for $20? Okay, dimensional analysis is a set of steps to follow using that given relationship that we already know. So let's look at an actual question. How many inches are there in 10.50 centimeters? Well, to answer that question, we do need to know what the relationship already is between inches and centimeters. And that's what's written in parentheses. 1 inch is 2.54 centimeters. So using that relationship, well, how many inches would you have in 10.50 centimeters? Okay. Now, half of you probably already have answered that question in your head. You already know how to do conversions between things. Okay, that's really cool. You have your answer, that's fine. But this video is not about getting the answer. This video is to show you how to use dimensional analysis to get the answer. Because for chemistry, we must learn how to use dimensional analysis. This is mandatory. Everyone must show skill in using this tool. So we're going to look back at the steps. Step 1 for answering the question. It says write the relationships between the given and the unknown unit. So if we go back to the question, the given unit is the information with the number in the question, what you are given to start with. We are given 10.50 centimeters. That's what we have. I have 10.50 centimeters. The unknown is how many inches are in that. So your unknown unit is inches. The given unit was centimeters. So the relationship between inches and centimeters is what is given to you in parentheses. 1 inch is 2.54 centimeters. That's your relationship. So your relationship is what's going to tie one thing to the other. And that's what step 1 is saying. Write your relationship. Since centimeters and inches have a direct relationship, we don't have to worry about any other relationships But if I feel like doing another video, I'll show you what I mean by that, where you have to go through a set of relationships just to answer the question. Step 2, though. Write all relationships as conversion factors. So if you're familiar with conversion factors from my course or from some other class, we know that a conversion factor is just a relationship, which you see 3 examples here. The relationships will be written as a fraction. Very simple, very easy. What do I mean by that? This is what I mean. If you look at this first relationship, we have $1 equals 4 quarters. So I can write that as, actually, let me keep that there. I'll erase the stuff on the bottom. If $1 equals 4 quarters, to write that as a fraction, I'm simply just going to say $1. What in the heck is wrong with me today? Sick. $1 equals 4 quarters, so I'm going to write $1 on top of 4 quarters. Okay, that's a fraction. I just wrote one thing above the other. Simple fraction. I could also write it the other way, because who says that it has to be $1 over 4 quarters? It could be 4 quarters over $1. Okay, is there a difference between me saying $1 is 4 quarters and 4 quarters is $1? There is no difference between that. Okay, so I can write the fraction either way. The only time that the fraction orientation matters is when we actually do the train track step of dimension analysis, which is going to come a little later. Okay, $1 over 4 quarters or 4 quarters over $1. This is what we call a conversion factor. It is a relationship written as a fraction. Very basic. And that was step 2. So if you go back to the problem, here is our relationship. We need to write that as a conversion factor. So I'm just going to say, well, 1 inch over 2.54 centimeters. Or I can say 2.54 centimeters over 1 inch. Okay, these are your conversion factors. Both of them are conversion factors. Now, we're only going to use one of them to answer this question. But you want to get into the habit of writing your conversion factor one way and then just flipping it. We called that the reciprocal in math class. Okay, so there you go. There's that step. Very basic. One on the top, one on the bottom, and then just flip it. Excuse me, snorting my nose. I am very sick. I am really dying. Here to breathe. All right, step 3. Set up your train tracks. Place the given data in the starting box and drop the unit low. Or as I say, drop it low, low. So what do I mean by that? Setting up your train tracks. This is what I mean. So you have your train tracks here. Let me actually get the question out. No, I'll go ahead and hide it. So here's what I mean by train tracks, but looking at it a second time looks more like a stitch face, but whatever. So you have your train tracks. So you want to draw just one long horizontal line and then put a few short vertical lines in there. Okay, we call this the train tracks. And the steps said to put your starting information in the starting box. Well, where's the starting box? It is the first box in your top left. Let's go ahead and highlight that. This is the starting box in dimensional analysis. Usually you will have the number 1 down here. You don't really have to worry about that unless you have 2 units, a unit on top of a unit in the problem, but that's beyond what we have to worry about for right now. So the blue box that I have written right here, that's your starting box for the train track. So we're going to put the given information in there. The given information was what was given to you in the problem. And then for us, I do believe it was 10.50 centimeters, but let me pull it back up. Yeah, 10.50 centimeters. That was given to us, and we want to convert that to inches. So I'm going to put 10.50 centimeters. Oops. .50 centimeters goes in the first box. Notice I wrote the number and the unit. That is important. And then the step said to drop the unit low, or as I say, drop it low, just like the song. What are we dropping low, though? We're dropping the unit, just the unit. And where am I dropping it? Diagonally to the bottom right. So it's going to go into this box. So we're going to put centimeters down here. Centimeters was the unit in the starting box, so you drop the unit low, so centimeters goes in the next box to the bottom right. What we're going to do next, though, is try to figure out what goes there and what's going to go above it as well. Okay? So that's where we're going to go back to our steps. Next step, step 4. So we're done step 1, step 2, step 3. Step 4, fill in the stacked boxes with conversion factors that match the unit on the bottom. So let's go back here. So if you look at the stacked boxes, we're talking about boxes that are on top of each other here. This long horizontal line is pretty much your division line, or the line that you have in your fractions, okay? So we want to know what goes in the boxes. We're going to check the unit on the bottom. We just dropped that unit low. You had to. You just do it. You don't worry about why. Just do it. And everything else is going to make sense. So we have centimeters down here. So what we need to do is go back to our conversion factors. Let's go back to our conversion factors. I hope I didn't erase it. There we go. Go back to your conversion factors. The train tracks made us drop centimeters low. So here, which conversion factor has centimeters low, or centimeters on the bottom? Okay. In the denominator to the left, we have centimeters. Let me highlight that for you. We have centimeters on the bottom. The conversion factor on the left has centimeters on the bottom. The conversion factor on the right has inches on the bottom. So you want to pick out the conversion factor that has the unit on the bottom matching the unit that's on the bottom of your train tracks. So just for reference, if you go back to the train tracks, we have centimeters on the bottom. So we need to use the conversion factor that also has centimeters on the bottom. That's the one on the left. This conversion factor. It says 1 inch on top of 2.54 centimeters. So what you're going to do is take that conversion factor and actually stick it into the boxes. So let me erase. Why did I write centimeters on the top? I have no idea. Blame that on me being sick. And I'm too lazy to redo this whole entire video. It's been 13 minutes of my life. I will never get back. So we're going to roll with it. That conversion factor had 1 inch up here. The conversion factor, what did it have on the bottom? 2.54 centimeters. And let's keep it color coded. That was the conversion factor. So that's what's going to go in the box. 1 inch on top of 2.54 centimeters. So let's go back to our steps. The steps say, if the top box does not have the unit of the unknown, what we're looking for, then drop that unit low and repeat step 4 and 5 until the last box has your desired unit. So basically what we're saying here is, if you have a unit on the top and that's not the unit we're looking for, then we're going to drop that low and get rid of it, just like we did with the starting information. And you repeat that process until you have the unit at the top that you want. What do I mean? Well, if you look right here where it said centimeters, at first that was the only thing we had here, and we didn't want it. We wanted inches. So we dropped centimeters low, picked the conversion factor that we wanted, and we put that in. Now we have inches at the top, and that is what we want, because the question said how many inches were in 10.50 centimeters. We want inches. So that means we are probably done with setting up our problem. If we go back to the steps, step 6, cancel out units that appear on both the top and the bottom side of the tracks. Top side of the tracks, we have centimeters here and we have inches here. On the bottom of the tracks, we have centimeters. So centimeters is showing up on the top side and the bottom side. So we are going to cancel centimeters out. No, I did not say cancel out the numbers. You can cancel out numbers if the number shows up on the top side and the bottom side. If I had 10.50 up here and for some reason 10.50 was on the bottom, then that can cancel out too, okay? But the unit is up on the top and the unit is on the bottom, so that and only that can be canceled out. We have nothing else that can be canceled out, so there's nothing further we can do regarding that step. So let's go back to our steps. Next step, step 7. Multiply all of the numbers on the top side. Multiply all the numbers on the bottom side. So if we go back to what we have in our train tracks, we don't even need these tracks. Let me just erase these to make more room. On the top side, we have 10.50, and I'm not going to write 10.50 cm because we got rid of cm. We have 10.50. We're going to multiply that by 1 inch. Okay? We're going to multiply that out. Well, let me come down here with it. 10.50 times 1 is 10.50. And you have 1 inch. So 10.50 times 1 inch is 10.50 inches. And we're going to do the same thing on the bottom. On the bottom, you have just 2.54. So we're just going to write that again. We don't have 2.54 cm because we got rid of that because it was on the top and the bottom. So we're going to bring that down here as well, 2.54. Okay? So we multiplied everything on the top. We multiplied everything on the bottom side. And then the last step is to divide the top result by the bottom result. So we come back here. We have 10.50 divided by 2.54. 10.50 inches divided by 2.54. If you go to a calculator app, 10.50 divided by 2.54 is approximately 4.13. So 4.13 is the result you get. We have inches still there. So that means the answer. There are 4.13 inches inside of 10.50 inches. And that's how you use dimensional analysis. Some of you may be thinking, well, that's a lot of work to do. This video is going on like 18 minutes. Like, that's a long time. That's a lot of work just to go between the two of those. I knew already that I had to just take 10.50 centimeter inches or whatnot. What was it, centimeters? I just take 10.50 centimeters divided by 2.54. Yeah, that's cool and that's fine. Yes, go for it. But this video was not to show you how to convert between units. This video was more so on how to use dimensional analysis. And that's the key, because we will be doing much more difficult problems with much more complicated procedures and steps, and you want to use dimensional analysis to get that done. So let's speed through one quick problem using the same steps, just so you can see how the steps are used. And it's going to be a lot more quicker. I'm not going to refer back to the steps over and over. You can just rewind or pause the video as you see fit. So here's the question I'm going to answer very quickly using dimensional analysis. How many weeks are in 18 days? And we all know that 1 week equals 7 days. All right. So first, write your relationship. It's already written here. 1 week is 7 days. The given is whatever has a number to it in the question. So the given is 18 days. That's what we have. And we want to know how many weeks are in that. So that is the unknown that we're looking for. We're looking for weeks. And they gave us 18 days. So here's the relationship. So you will write that as a conversion factor. You can say that 1 week equals 7 days. So 1 week over 7 days. Or I could just as easily say 7 days. No. 7 days is 1 week, and I feel like each time I talk, my nose stops one extra oxygen molecule from coming up in my nose. Oh my God. I can barely breathe. Excuse me. Yet I still talk. 1 week over 7 days, or you can say 7 days over 1 week. So both of these are conversion factors. All right, so the next step was to do or draw a train track. It's going to be kind of short, so I'm just going to do this for now. And you can put the given info in the starting box. The given was 18 days, so I'm going to write 18 days here. And you immediately drop it low. So we take the unit, just the unit, and we drop it down to the bottom right box. So that means you have to write days down here. You just have to do it. You don't have to think why, you just do it. Okay? You put days down here, we go back to our conversion factors. We have 2 of them. Which one has days on the bottom? This one does, not that one. This one has days on the bottom, and we have days on the bottom here. So that means fill in the info. 7 days on the bottom, and on top you had 1 week. So 1 week. All right. Now, since we are looking for weeks and we have weeks on the top, that means we're done. We don't have to proceed with dropping more things low. Sorry, I can't make a longer video to show you all that. It's already a struggle to talk while being sick. All right, so the next step said to, if you had units that show up on the top and the bottom, you can cancel them out. And we got days on the top and days on the bottom, so days and days can go away. Next, all the stuff on the top, you want to multiply. So that means we have 18 times 1 week on the top. And on the bottom, we just have the number 7. So that goes there. 18 times 1 week is 18 weeks. And on the bottom, you have 7. And you can do 18 divided by 7. 18 divided by 7 is about 2.57. So the answer, 2.57 weeks. And I need to blow my nose. There you go.